Hi guys, in this video I'm going to attempt to describe what the product rule is and its uses. So basically the product rule is a tool that we use for differentiating functions that are made up of two smaller functions. What I mean by that is if we have a function y in terms of x, it's made up of two functions which are multiplied together. So I'm going to f of x times, and I'll change color to make it more easy to see, times g of x. So the product rule is used for differentiating functions which are a product of two smaller functions, or inside functions you'd say. So the way that we would differentiate this, or the product rule states that if we've got a function like this, that its derivative will be equal to the derivative of the first inside function times the second one left constant, so we don't touch it at all, and then we add it to the first function left constant multiplied by the derivative of the second function. So this rule or tool is used, or is very useful, for when we're differentiating functions which are made up of the product of two other functions, because it makes the algebra a lot easier when we're trying to come out with a usable derivative in the end. So I'll give you a couple of examples on how we would use this in either a test or an exam, or in the real world if you ever needed to find a gradient function. So what I'll do, I'll just separate the pure maths. So if we were given some sort of function y is equal to x cubed plus 3x squared multiplied by 2x squared plus 4x before you would have discovered the product rule, the only way to differentiate this function would be to multiply out this binomial and then differentiate it. So you'd be left with some quite large numbers, and the algebra can be a pain. But what we would do using the product rule is we would identify our two different functions. So in this case we have the first function, this is f of x, and we have our second function, which is here, g of x. So you can see you've got a cubic function which is multiplied by a quadratic function. So what our product rule states is the derivative of this, dy dx, is going to be equal to the derivative of our first function. So that's going to be 3x squared plus 6x, and we multiply that by the second function being left alone, we then add that to the first function being left alone, multiplied by the derivative of the second function, which is 4x plus 4. So there you have it. That is the derivative of this function. Now, if we were to try and evaluate this derivative, it would be a lot faster to do it this way than to multiply out the brackets of this and then differentiate and then evaluate it. So let's do another example. So that's example 1. Let's try example 2 over here. I'll change the color. So example 2, we have y equals e to the x tan of x. So what we have is we have our first function, and we have our second function. So the derivative of this thing is going to be equal to the derivative of the first function. Now the derivative of e to the x is a special one where the derivative of e to the x is e to the x times the second function left alone plus the first function left alone times the derivative of the second function. So the derivative of the second function is 1 over cos squared x. And we can clean this up a little bit to e to the x tan of x plus e to the x divided by cos squared of x. So there you have it. The product rule is not too complicated once you understand what you're looking for. And once you understand what you're looking for, the application of the product rule isn't too difficult. Now, just in recap, we use it when we have a function that is the product of two other functions. And if we have this situation, our derivative will be the derivative of the total derivative will be the derivative of the first function times the second function, plus the first function times the derivative of the second function. And if you've got that under control, I'm fairly sure that you won't have any trouble with solving these derivative problems. Thanks for watching. I'll see you again next time.